final serial element to discuss is trichord register, which is the one I personally found the most confusing. First of all, who remembers what a trichord is? 3 notes?
Coordinated.
Yes, and it doesn't necessarily have to be triadic. Correct. Check out graph 4 on the handout. What it's showing is that each row can be sliced into 4 trichords, and the direction of the notes in a trichord depend on which row is being used. Bear with me, I know this is really confusing. Take a look at the right hand and measure 11. So flip back to Alright, so measure 11. Do you guys see the 4 trichords there in the right hand? And then there's 4 other ones in the left hand? Okay. The row being presented in the right hand is I1, and according to graph 3, since it's an inversion row, it's going to use the dynamic forte, which it does, and have a 16th note pattern of 1, 5, 2, 4. So if you take each trichord and you count how many 16th notes it's worth, what pattern do you get?
Say that again.
If you look at each trichord in the right hand and measure it out for how many 16th notes it's worth. Exactly. You get a 1, 5, 2, 4 grouping, which is goes with the I rows. Isn't that cool how they match up? Okay, so now let's take it a step further. What does graph 4 say about inversion trichords? That's the sideways one. It has a lot of ups and downs on it. Down, up, down, up. Alright, so which means if you hold up graph 1, which is the matrix, next to the score, you can see that the first 3 notes of I1 are D, F sharp, and E. And do you see how they go down the chord? D is the top note, F sharp is the second, E is the third. And then the next are going to go up the chord. So the next 3 notes are going to be G, A, and G sharp. You see how they go up the second chord? Go with G and an A and a G sharp on top. And then the next 3, D, B flat, and E, are going to go down. Oh, D, B flat, and E flat, sorry. Are going to go down the chord. And the final 3 notes, we have C, C sharp, and F. And then in the fourth, we have starting at the bottom, C, D flat, or C sharp, and F. And it actually works that way for all the trichords in the piece. Okay, moving on to combinatoriality. Who remembers what that is? Tom? Oh, sorry.
It's all you.
You can take half of a row and then you can add it to any other row as long as there's no duplicate notes.
Exactly, but what do you call half of a row?
Combinatorial row?
6 notes.
Hexachord.
Hexachord. Good. So if you split each of these 8 rows that he uses in half, you end up with an A hexachord and a B hexachord. And all the A's hexachords contain the same notes, but in a different order, as do all the B's. It's all laid out on graph 2. That's the final graph in there. And the box goes there, not sideways. So as you can see, all 8 rows are split in half, and they follow the order listed in the little box above. For example, P0 features an A hexachord followed by a B hexachord. Then if you take another row, say RI7, that features a B followed by an A, which means that if you take the first 6 notes from P0 and the first 6 notes of RI7, you get all 12 notes. You have a different row. The same will happen if you take the first 6 from P0 and the last 6 from I7. You guys see how that works? They're all A and B. They can all be combined differently. So there is one other special thing about these rows. Well, there are many special things about these rows, but one other one that I want to point out to you today. I gave you guys a little activity to do on your handout, so just turn to the front page. It's a groomed Gestalt activity. So I want each of you guys to mark the intervals between each of the notes. For instance, the first 2 we have B flat to E flat. What is that? Perfect chord. And go through and do all the intervals, and then tell me if you see a certain pattern, something interesting. Raise your hand. Wait, we do. Give us some time, Tyler. Tom?
Does it include all of the intervals?
It
Every
does.
interval?
It's an all interval row. And guess what? So are the other 7.
Oh, really?
So just write on your handout, all 8 rows are all interval rows. Alright. I had so much fun doing this, like math problems in my apartment. Wonderful. Okay, so lastly, I want to talk about form and structure in this piece. I see it as a ternary form with 8 measure A sections, and the rest is just a large B section that can be subdivided. The first 8 measures present all 8 rows, as I showed you guys, and so do the last measures. The B sections can be divided into smaller subsections that are usually delineated by a meter change or a significant rest in one or both hands. So I have that all listed out on the handout, so you guys can mark in the section. Actually, let's do that right now. So we have section 1, starting at measure 1, that's A. And then section 2 begins at measure 9, so the time changes to 4. And that starts the B section, with subsection 2. And then within the B section, we have subsection 3 that starts at the beginning of measure 19. So mark that as 3. Yep. Third system down. Measure 19. And then we have section 4, also within the B section, and that's the magic triangle, measure 29. And still within B, we have section 5, and that's in measure 39, bottom system on page 564. And then the final section is the return to A on page 565, and it's up the magic triangle on that section 6. Okay. The piece in and of itself is nearly palindromic, actually. There are a few adjustments. It's not exactly palindromic. Do you guys remember what that means? Okay. For instance, if you compare the first 2 measures of the piece, and then flip the page and look at the last 2 measures, you see how they're an exact retrograde of each other. But instead of P0, P6, there are 0 and 6. Pretty awesome. So now that you've learned the methods to Babbitt's madness in composing his piece, perhaps it will soften the blow of actually listening to it. And hopefully, through your newfound knowledge, you will have acquired a deeper appreciation for integral serialism. But first, do you guys have any questions? Before we take a listen.